This is the first video in the Chemical Reactions Predicting Products series. In this segment of the series, we will focus on predicting products for synthesis reactions. What is a synthesis reaction? It's a chemical change in which two or more substances form a single new substance. So given this generic equation, A plus B, we have a single product. Just one product is what you need to be able to identify a reaction as a synthesis reaction. One example of a synthesis reaction involves combining a metal with a nonmetal. When that occurs, we end up with an ionic compound, also known as a salt. When a group A metal and a nonmetal react, the product is an ionic compound. Let's take a look at potassium combining with chlorine. When these two are combined in a synthesis reaction, the product is potassium chloride. Once you write the formula of the ionic compound down, then you just balance the reaction by adding coefficients. Another example of a synthesis reaction occurs when combining a transition metal or a multiple oxidation metal and a nonmetal. When that occurs, more than one product can also be the result of this reaction. For example, when we combine iron and sulfur, we can obtain either iron 2 sulfide or iron 3 sulfide. Transition metals such as iron are capable of adopting multiple positive charges within their ionic compounds. Therefore, most transition metals are capable of forming different products in a synthesis reaction. Another type of synthesis reaction we can look at is when two nonmetals react. More than one product is often possible. If we take a look at carbon and oxygen, the product of these two reactants is usually carbon dioxide. But when the air or the oxygen supply is restricted, incomplete combustion can result in the production of carbon monoxide. Now let's take a look at how to generally predict the products of a synthesis reaction. The example we'll look at is combining aluminum and oxygen. The first thing you should do is write down the symbols for each of these elements. Aluminum plus oxygen. Remember, oxygen is a diatomic molecule, so you must put a 2 as a subscript after writing the symbol for oxygen. Next, make sure, if we're looking at a metal plus a nonmetal, to write the cation or the metal first as the product. Remember not to transfer subscripts when writing the formula of the product. Instead, use the oxidation numbers. So aluminum's oxidation number is +3. Remember, it's a group 13 or a group 3A metal. And oxygen has an oxidation state of -2. When you write the formula for aluminum oxide, the product of the aluminum and oxygen synthesis reaction, you will need 2 aluminum ions and 3 oxide ions to make a neutral compound of aluminum oxide. The final step will then be to balance the chemical equation by using coefficients. So our final result of the synthesis reaction is 4 aluminums plus 3 oxygen molecules, yielding 2 aluminum oxide formula units. Let's practice by writing the products of a few synthesis reactions. In number 1, we have potassium plus bromine, a diatomic molecule. Remember, potassium forms a +1 ion, and bromine, a halogen, forms a -1 ion. We only need one of each ion to form a neutral salt of potassium bromide. So the product can be written as KBr, just one of each ion. Now we need to balance the equation by adding coefficients. We should put a 2 in front of the product, the potassium bromide, and a 2 in front of the potassium. So our coefficients for this balanced equation are 2, 1, 2. In the second example, we have sodium plus bromine. Sodium, like potassium, is an alkali metal, so it also has an oxidation state of +1. Bromine is still -1. The product for the synthesis reaction of these two elements will be sodium bromide, one of each ion. Our next step would be to add coefficients to balance the equation. We would put a 2 in front of the sodium bromide and another coefficient of 2 in front of the sodium. So our coefficients for this balanced equation are also 2, 1, 2. Take a moment to try the next 3 examples on your own. Pause the video and then check to see if you got the right answers. These are the products. You'll notice that the equations are also balanced because there are coefficients included in the chemical equation. Remember, the key to identifying a synthesis reaction is to make sure that there's only one product in the chemical equation.